Hello, hello, guys and gals. Welcome to our second video of practice problems. In this one, we'll probably get through 4 and 5. We probably won't get much farther than that, okay? So in practice problem 4, we're looking at the chemical reaction between nitrogen monoxide and oxygen gas to produce nitrogen dioxide. And they are telling us that the rate of disappearance of nitrogen monoxide is 5.0 times 10 to the negative fifth. They want to know the rate of disappearance of oxygen under the same conditions. And so if we didn't know what section this was coming from, because you know that this is coming right after the relative rate section, right? But on the AP exam, you won't. So here's what we need to do. We need to say, okay, I have the balanced chemical equation, and I have the rate of one of my reactants, and that's it. I have no experimental data. I have no rate law. I have nothing else. All I have is the balanced chemical equation and the rate of disappearance of one of my reactants. That's going to be a big neon flashing sign to you that this is a relative rate equation or a relative rate problem, right? And so what do we do with relative rate problems? We set them up. We say, okay, this is rate of disappearance, so it's negative. We put 1 over the stoichiometric coefficient. The stoichiometric coefficient in front of nitrogen monoxide was 2, so we're going to say 1 over 2. Then we're going to multiply that by the rate of disappearance of our nitrogen monoxide, which was 5.0 times 10 to the negative fifth. Right? Am I crazy? Yes. No, we're good. All right. And we're going to set that equal to the rate of disappearance, so negative of 1 over 1, because the stoichiometric coefficient in front of oxygen was 1, and times that by x, because the rate of disappearance of oxygen is what we're looking for. So then we can just solve this algebraically. Half times 5.0 times 10 to the negative fifth gives you 2.5 times 10 to the negative fifth is equal to negative 1 over 1 times x. Obviously, we would divide by 1. When you divide by 1, it's just going to give you the number. So the rate of disappearance of oxygen is just 2.5 times 10 to the negative fifth molarity per second. Okay, so now that we know that, we can go and see what our answer should be. I can see immediately that the only answer choice that contains the math that we just came up with is A. A is the only one that says the rate of disappearance of oxygen should be 2.5 times 10 to the negative fifth. Let's make sure the first half of A makes sense, because if it doesn't, we did something wrong, right? So, because 2 molecules of nitrogen monoxide are consumed per molecule of O2, the rate of disappearance of O2 is 2.5 times 10 to the negative fifth. Is that true? Are 2 moles of nitrogen monoxide consumed for every 1 mole of oxygen? Yes, they are. That's what the balanced chemical equation is telling you right there. So our correct answer is A. And if you were on the AP exam, I would tell you to take that and run with it. Go. Don't even look, because you really don't have the time. You can star it if you want to come back and check it later. But we're not on the AP exam. So I'm going to go through the other sections. I'm going to show you why they're wrong or tell you what you're looking for to know that they're wrong in those. But on the AP exam, you should take A and you should go. Okay? In B, the first part is the same. So the first part is correct in B. It's the second part that's wrong. Somehow they got 1.0 times 10 to the negative fourth. Well, 1.0 times 10 to the negative fourth is about double of 5.0 times 10 to the negative fifth. So you know what they did? They did not turn these into fractions. They kept them the stoichiometric coefficients. So you've got 2 times 5.0 times 10 to the negative fifth is equal to 1 over x. And so they get 1.0 times 10 to the negative fourth. But, okay, that doesn't make sense, right? It is a 2-to-1 ratio, so why doesn't this work? Let's look at our ratios, okay? We know that nitrogen monoxide to oxygen gas is a 2-to-1 ratio, okay? Based on our math, that ratio stayed the same. We had 5.0 times 10 to the negative fifth. Our answer was 2.5 times 10 to the negative fifth. If you look at that, that is still a 2-to-1 ratio. But if you keep the stoichiometric coefficients the same and you don't turn them into fractions, you would have gotten 5.0 times 10 to the negative fifth to 1.0 times 10 to the negative fourth. You would have flipped your ratio basically. This is a 1 to 2 ratio, not a 2 to 1 ratio. They're not the same, right? You can't just decide to flip which one's supposed to be larger. So you can do this problem however you want. If you want to set up the fractions, just put 1 over your stoichiometric coefficient and solve for it regularly. Or you can go through and you can do this. You can solve for it using the ratio. As long as your ratio stays the same, that's fine. The biggest point is you have to keep this ratio the same. And also you are going to see those fractions on the AP exam, so you need to be familiar with them. So B is wrong because they did not turn their coefficients into fractions and therefore they messed up their ratio. Okay? Now C says the rate depends on the concentration of nitrogen monoxide squared and the concentration of oxygen gas, and the rate of disappearance is 2.5 times 10 to the negative ninth. Well, besides the fact that I literally have no idea how they would have gotten 2.5 times 10 to the negative ninth unless they added something instead of dividing it or multiplying it, you have no idea where this came from. Why is the concentration of NO squared? You can't do things like that without having experimental data. And so that's what they're trying to play on here. In the future, you will understand how to get information like that. Right now, you don't know that. But in the future, you're going to be like, oh yeah, that might make sense. The problem is you cannot get that information unless you have experimental data. They got to give you a big table or a big graph in order for you to be able to figure that out, which they did not do in practice problem 4. So we know that C is wrong for 2 reasons. First of all, we know that C is wrong because their math makes no sense. Second of all, we know that C is wrong because you cannot get information like this without having experimental data, okay? So right now, it's easy for you to just look at the math and say, oh, it's wrong, I don't really care about the other piece. In the future, you're going to want to come back to this video and remind yourself that C is not the right answer because there's no experimental data to back this piece of information up, okay? Now let's look at D. Because oxygen is under the same experimental conditions as nitrogen monoxide, it is consumed at the same rate. That's just not true. That's not what this balanced chemical equation is telling you is happening. What this balanced chemical equation is saying is that 2 moles of nitrogen monoxide are consumed every time 1 mole of oxygen is. That's not equal. So their concentrations will not be changing at the same rate. Okay? So your answer to question number 4 is A. Let's take a look at question number 5. For the reaction represented above, the initial rate of decrease in X was 2.8 times 10 to the negative third. What was the initial rate of decrease in Y? And so this is basically the same problem, okay? It's the same problem, but with a different equation. So we have, let's see, the rate of decrease is negative 1 over 1 because the stoichiometric coefficient in front of X was 1. And it's going to be multiplied by 2.8 times 10 to the negative third. 2.8 times 10 to the negative third. Then we have a negative because we're still looking for the rate of decrease of Y. It's going to be negative 1 over 2. And that's going to be X because that's what we're solving for. So this one kind of just cancels out. We just get left with 2.8 times 10 to the negative third is equal to 1 over 2 times X. So, and this is a negative because it's rate of decrease. Algebraically, we're going to get 5.6 times 10 to the negative third is equal to X, right? So let's make sure that this number makes sense before we move on. X to Y is a 1 to 2 ratio. Did we keep this 1 to 2 ratio? 2.8 times 10 to the negative third to 5.6 times 10 to the negative third. Since they have the same exponent, we can literally just compare their numbers. 2.8 times 2 would be 5.6, right? So your correct answer here is going to be D to practice problem 5. All right, guys, let me know if you have any questions.